Hey everyone, welcome back to the channel. I hope you guys are doing really well. And in this today's challenge on Leetcode, we also have a very easy problem with us. Uh, Maximum level sum of a binary tree. Given the root of a binary tree and the level of the root is 1, level of its children is 2, and so on. Return the smallest level x such that the sum of all the values of nodes at level x is maximal. Okay, so you need to find the level orders. Sum of each and every level, whichever is the maximum, you need to return the level number of that. If there are multiple maximum, you need to return the smallest level. Okay, that is what it is meant in the question. So the only thing which you need to know is how to do level order traversal, and that is nothing but a simple BFS traversal. uh, yeah, I hope you would know that. If you do not know, you can watch a video on BFS traversal. So you use a queue in such a kind of traversal, and let's say this is your tree. How will you find the level order sum? Okay, you need to find this. This is level 1 sum, level 2 sum, level 3 sum, and so on. You need to find all the level sum, and whichever is maximum, you can keep updating your maximum variable as well as a level answer variable where you store the level. Okay, so yeah, you can do that. So at first you can just extract the root node and push it into the queue dot push root. Okay, and while queue is not empty, while queue is not empty, okay, you can just keep traversing, and every time what you will do is also push for every node I, just push is left and the right one. Also, if it is not null, you just push both of them into the queue. And while for doing this level order sum, what you can do, you can just inside the while you can just find let's say size of the queue to be queue dot size. Okay, and all your computation, all your pushing inside the queue and all you can do inside a while size minus minus. Okay, so what does it mean? So see, at this, when you are starting to process this node, this particular node, let me use a different color. When you are starting to process this particular node, you have the queue size to be 1. Okay, when you are starting to process this particular node, you have the queue size to be 2. So you want to yeah, I mean, yeah, I told a little bit wrong. You see, when you are when you are starting to level order traverse this level, okay, so you have these two elements in your queue, right? Because when you are in this node, you had pushed the left node and the right node. Okay, and when you are starting to traverse this row, this level, you have all these elements in the queue, because when you were processing this level, you had pushed these two elements. When you are processing this node, you had pushed these two elements. So the size of your queue is nothing but 4. So you should keep processing level order. It means that you should extract the size, and while size minus minus you should do. Okay, while size minus minus you should do, and also keep pushing elements in the queue only within this loop, so that what you can do inside this while loop you can keep some variable. Okay, and for you can just add things to your sum plus equals to, let's say, every node arrow value. Okay, so for every node arrow value, you just add that to the sum, and since this is the size of your level, you find the level order sum in this way. So as I will code, things will become very much clear, and if you already know level order traversal and how to find the level order sum, I guess this is a pretty trivial problem for you, and yeah, it's very simple also. So let's see. Mm, as I told you, I will want to have a queue, and the first thing which I will push in the queue is this root node. Okay, and what are all the things I will have? I will have an answer which I will initialize to 1. I will have the initial level which is 1. Uh, then I will also have sum and all, but that will be inside the loop. So while not of queue dot empty, so this while the queue is not empty, what you can do? At first you extract the size of the queue. Okay. Okay. So you also have a max value which will tell you that here this is the particular maximum value encountered so far. Okay, so you have this size, and while size is minus minus, you can just do this level order traversal, and you also need a sum, right? As I told you, the level order sum you need, and q dot what you can do for this, you can do sum plus equals to q node. So first you extract a node. Okay, so uh, tree node star nd is nothing but q dot front. Okay, so you just this and q dot pop. So this is a standard thing in BFS. So yeah, you have this node with you, and you just do node arrow val, and if node arrow left is not null, if the left and right values are not null, what you can do, you can push both of them in the queue, right? Q dot push node arrow left. Okay, and for the same thing you can do for the right one also. So yeah, you have it. Okay, so if node arrow left right is not null, you just push them also into the queue, and as you have pushed both of them, yeah, you have also popped after processing this. And here you can what you can do, if max is supposed to be less than, happens to be less than sum, you can update your maximum value, and you can update your answer to be the particular level. Okay, because you see this particular maximum value is found in this particular answer level, that is what you are storing, and yeah, that will be all right. You just need to remember to increment this level also. So at the end you can just simply return answer. I hope that will be pretty simple and straightforward. So this was basically a whole algorithm of BFS which I just implemented, along with a tracking of the level order sum as well as the particular level in which I am working. So if you try to run this, I hope this will work just fine. uh, let's see. Yeah, it does work fine, and if you try to submit it, it will also have a decent runtime complexity and all. Okay, so we are getting a wrong answer over here. So you need to see that if all the elements are negative, okay, there might be a possibility that all the elements are negative. So you cannot initialize your maximum to 0, right? You have to initialize to int min. I hope you do understand this. Okay, so let's try to submit it now and check if it works for all the cases. Yeah, it does work for all cases. Yeah, this is now giving 73% bits approx, but yeah, when I run it one more time, yeah, I had run it the same code previously, it gave me 100% runtime bits. So yeah, it varies a lot, this sum, if you see. Yeah, it the same exact code also gave me 100% runtime bits. Few minutes ago I had solved it. Okay, so yeah, I hope the problem was clear to you. I hope if you already know how to do a BFS traversal, this should be a pretty straightforward approach for you. So yeah, that's all for this video. I will meet you in the next video. Till then, thanks a lot.